Hey guys, it's Will Falcon, creator of PyTorch Lightning and founder of Lightning AI. So CodeLlama 70B dropped yesterday and I tested it a bit, but it couldn't get it to work. The model was running, but it wasn't really generating anything interesting. So I'm gonna try again today. But basically what I wanna do is test it out and compare it against Mixtral, which I've been using for coding, and then like another model like a Mistral 7B. So I'm gonna get started here real quick. And by the way, in this video, I'm not going to edit anything, and I just want to show you guys like what a real workflow looks like, and hopefully things work out. So I'm going to be trying to get this model to generate some code for me, like a ResNet 50 fine-tuning code. ResNet 50 is a type of model for computer vision, but it really works for any other type of model. I'm just more familiar with computer vision. All right, so CodeLlama 70B. Can click Run Free here. If you don't have an account, create one, it's free, and the studio will run for free as well, and you get free credits. All right, so I'm gonna do that here, and I already have one, so I'm not gonna click that button. Okay, so this is going to duplicate the studio. I'll explain that in a minute. So I'm gonna start 3 of these. This is 70B instruct, and then I'm going to use Mixtral, mixture of experts here, and I'm going to then use let's see, Mistral 7B, right? All right, so 3 models that I'm going to be comparing. All right, so while this happens, so what's happening right now is we're duplicating these 3 studios. So the studios, think about it this way. I'm actually gonna, so this is 70 billion parameter, but this is a CPU, so obviously it's not gonna work. I'm gonna run this thing on an A10G. I think it's like the best bang for your buck, honestly. A lot of people are like obsessed with A100s and H100s, and you might need them for certain use cases, but there's a lot of stuff you can do on A10Gs. Okay, so what we're doing here is we've duplicated the studios, and a studio, think about it like a laptop, right? Like imagine you have a laptop, like you buy a brand new laptop. That's what a new studio is, just like an empty laptop. And then you get on there and you install whatever you want, you load all the files, etc. You set it up perfectly. So you don't have to like create con environments or anything because it's only a single laptop, right? And you're only gonna have 1 studio per project, so 1 studio per thing that you're doing, so 1 environment. Now, when you want to share that with people, you can't like ship your laptop to people today, right? And like if you were to not use Lightning, you'd have to like be like, here, some GitHub code, and like here's this Docker image, and build this and that, and like maybe next week they get it running. On Studio, you publish a studio, someone duplicates, and it just works out of the box. It's literally like a photocopy of your laptop, which I just did here, right? So this was published yesterday. It took us like 30 minutes to put together. And so this actually, what these 3 are doing, they're deploying this model on the studio. So there's an endpoint running on the studio here. And we're just happening to be using a notebook as an interface. So I like notebook interfaces for these things because, especially for coding, because like I can code back and forth. Now, I generally don't run code in notebooks, so I use it to find the code and then run it separately, which I'll show you as well. Okay, so I've got these 3 running here. Let's see. Mixture of experts, it's up. And Mistral 7B is up. So, and they're all on A10Gs. Love it. All right, so sometimes it might take a bit to load the checkpoint, so I'm just gonna run it real quick and see how this works. And hopefully I get impressed by Llama 70B. All right, so hey, count to 10 in Python. All right, let's see. So I'm gonna test this model and give it a coding interview. Actually, that would be interesting. Someone should definitely give a model a coding interview, like in real time, and see how that works. Yeah, it's gonna be a lot of unstructured thoughts, so hopefully you follow along. Okay, this thing's gonna be up and running, and almost there. All right, while these models load, I'm just gonna give you a quick tour of the studio. So you've got metrics here. You can see that there's a bunch of utilization just now to like set up the model, deploy the endpoint, all that stuff here. You've got RAM, disk usage, etc. And you can kind of break out these windows into their own and like have your own thing running, right? And see what it's doing. I can also connect from my local VSCode. So I can just grab this code here, paste it in my current VSCode, which I'm gonna show you real quick, right? And then this is my local machine. And then I just paste that, sets it up in a few minutes. and I'm good to go. All right, and I'm on the studio right now. And I'm just gonna create a new file called finetune.py. Now, I'm actually not gonna code from my laptop. Yeah, I don't really need to install this right now. But if you go back to the studio, you see that the file is there, right? So it's all great. I prefer coding from the browser for these kind of things. And there's really not that much difference. Okay. All right, so 70B still going, has not loaded. Looks like probably still loading. So I'll give it a few minutes. And then I'm gonna use the same prompt for our friend Mixtral. This is my favorite model for coding right now, right? This one works really well. I don't even use ChatGPT anymore for these things. Although ChatGPT is great. Also, no hate on ChatGPT. I just rather have the context of like running this in a notebook and actually be coding and have the machines and all that. You can do a lot more. Okay. And let's see if this other one's running. Mistral 7B. Yeah, all right. So I'm just gonna copy. Don't we have something here? Yeah. Look at that. All right, Mixtral coming in strong. And you can just run the code, which is sick. Boom, done. All right. Llama 70B, still going slow. So, yeah, maybe an A100 here wouldn't be terrible, but you know, like this model is still big, but it fits in memory and it's pretty fast. So not terrible, especially for like personal coding, right? Because like you don't necessarily have to rely on an external API. What if they go down? What about your data, your code? Everything that we're doing here, it's not even saved anywhere. It's literally in the context of the notebook. Like it couldn't be more secure if you ask for it, right? Okay, so let me copy the syntax here real quick, so I'm not like dealing with this thing. Clients, chats. I don't actually know. What am I doing here? Okay, I'm just gonna do this. All right. Yeah, I don't know why this has different APIs. Chatbots. In Python. Okay, cool. Here we go. All right. There are a lot of open source tools that we're doing. Oh, wow. So I guess it's just interesting. Oh, I'm silly. Huh. That's like, what's going on? Okay. Under the hood, we're using something called Llama here as well. There's a bunch of open source stuff that's here at work. But I think there's, open source community has done a really good job of getting a lot of these things to work. Obviously, we've done a lot of work on there as well, so it's a combination of many things. Okay, CodeLlama. Yeah, totally off. I don't know what it's doing. Look, I played with it yesterday a bit. This thing over-engineers. Let me just tell you that much. Maybe more parameters is not better for coding because probably it will over-engineer, right? But that's just me speculating without any real context here. Okay, so let's go ahead and prompt this thing. All right, so my prompt's going to be prompt equals, and I'm going to put a pretty long prompt. So create a Python program to fine-tune a ResNet 50 on CFAR 10 using PyTorch Lightning. So ResNet 50 is a type of model, computer vision. Sure, it still works pretty well. It's not a transformer. It's kind of like a different architecture, residual networks. CFAR 10, it's a academic data set, right? In the real world, you would just like attach an S3 bucket here, right? So I could just kind of do this real quick. So I can say, hey, give me an S3 bucket. I uploaded, let's say it's ImageNet here. I set it up. It takes like 3 seconds to do. If it's a private bucket, you got to authorize it. It's fine. And now I've got this path and see the data's there already. So I can literally start using this right now, right? So this took a few seconds to do. Import os files equals os.list there. Right. There you go. So the data set's already ready to go. So really not that much different on Lightning. Lightning makes things extremely simple for these kind of things, especially data and like moving data around and stuff like that. Okay, C410 using PyTorch Lightning, and then PyTorch Lightning is our open source framework for fine tuning and pre-training models, right? It was built in 2019, 2020. Over many years, I open sourced it in 2019, but really is originally designed for AI research. Still today is one of the most widely used libraries for that. But turns out that it's really good for scaling models. So anyone who's been fine-tuning or training at scale is using PyTorch Lightning today to do it, including the biggest companies in the world. So I'm going to show you why, because we're going to take, hopefully when this thing gives me real code, I'm going to run a CPU, multiple GPUs, and then scale it to multi-node. No problem. So everyone's complaining, oh, fine-tuning, pre-training, super hard. It's not. You just don't have the right tools, right? Okay, so Python program, fine-tune Resonance 50 from Torch Vision. I don't want to deal with trying to set up other models. Using PyTorch Lightning, and I'm gonna, these models do tend to over-engineer, so I'm gonna just try to make it simple. So do not use data module, although you can, it's a PyTorch Lightning thing. Use regular data loaders. Do not forget to implement the configure optimizers method. Use only the training and val splits, and do not use learning rate scheduler. Okay, prompt, love it. And here we go. Let's see how this thing will do. Where's my prompt? Okay, prompt. So it feels like where I'm like putting Llama against Mixtral and this and that. I'm not. Remember, Mistral, they all come from Llama anyways. So it's all the Llama gods at work here at the end of the day, courtesy of Meta. Love the work that they've been doing. I did a lot of my PhD at FAIR, Facebook AI Research. One of the main reasons I went there is because Facebook is so good about open source and, so even supported me building PyTorch Lightning as well when I brought it in-house from my PhD. So again, I think they're the leaders in open source today and open source AI, so highly recommend. All right, and let's grab this prompt and feed it to Llama 70B. Moment of truth. Let's see how this thing works. Prompt. And it's going to take a while, I assume, because it's a huge model. All right, come on, model. Yesterday when I used this model, it over-engineered and it was lazy. It didn't give me all the code right. I don't know if I have to tip it or whatever. I'm not sitting here prompting models all day. So you guys got to tell me how to do this. All right. So yeah, this wasn't quite right code. So low hopes, but let's see what happens. This is Mistral 7B, right? So let's see here. All right. So let's see what happens. All right, Mixtral though, done. Amazing, love it. Guys, this is wild. This is an A10G, right? This thing that I'm running will cost me a few dollars an hour. And you already get free credits in Lightning, so it's actually free, right? Okay, so moment of truth. Let's see if I can just copy paste this thing and run it. Usually I would run it in the studio, in the notebook again. So let me just do that. And then I can iterate back and forth, right? But hopefully it works. Let's see. Oh my God. Did I get it on the first try? No. Oof. All right, train data loader. Yeah, it's using old syntax, so I'm just gonna delete this stuff. All right, you don't need any of this. You guys ever seen these trainers? So PyTorch Lightning created the first trainer ever, and many libraries have since then kind of adopted this pattern. But ours has been engineered a lot internally at Facebook as well, with a team there, and then also at NVIDIA and Google and so on. So it's got a lot of man hours behind it in the open source community. So it scales really well, right? So I would encourage you to use the trainer to fine-tune other models that are not even written with PyTorch Lightning specifically. Just as long as they're PyTorch models, that's fine. But this thing will scale to multi-node, super flexible. What else? Oh yeah, the trainer also detects the GPUs automatically. So if you see it's already running on this GPU, but hey, this is really cool. So it looks like this model worked out of the box. I don't really have to do a lot, so pretty sick. So I'm going to drop this code into finetune here. I'm going to sanity check it again, and then I'm going to scale this thing to multi-node, because you can do that, and it is not that hard. Do not be frightened. The powers at will of the big corporations want you to believe that you should only pay certain big companies to host and deploy models for you because fine-tuning and pre-training is so hard. It is really not. I'm telling you, it's so easy. The open source community has made it extremely easy. Years ago when I started my PhD, zero chance it was that easy, right? Even at Facebook, we were struggling to do it. I mean, there were some teams that were really good, but that's what PyTorch Lightning solved pretty much for the world, right? And PyTorch has evolved a lot as well since then. Okay, so I'm spinning up Tensorboard here. So these are apps, by the way. So the studio has a bunch of apps to do many things. I showed you how to literally connect data sets. So in this case, I'm just monitoring this. So I just want to see what the Tensorboard situation looks like. So training loss looks good. It's fine. You can use your own loggers. It's all good. We don't care. It integrates pretty well with any tool. We designed Lightning Studios to integrate with any tool you like. Okay, so let me just keep this guy on the side for now. And in the meantime, let's just run this real quick. Okay, so one thing I want to show you, there's a bunch of GPU RAM being used right now. This is because the model is running. But luckily, ResNet 50 and CFAR 10 is not going to take up that much RAM. So I'm just going to run it real quick and make sure it doesn't out of memory. Boom. All right, so you see it kind of went up a bit right there. So that's the model. Power's, I think, the best way. We have profiling experts on the team. They know the stuff much better than I do, but turns out Power is much a better predictor of like what the model is actually doing or not. Our profiling lead was the profiling lead at Meta before, and then at TensorFlow before that at Google, right? So he's had a lot of experience doing this. So we get a lot of cool knowledge here. If you work with us, you'll obviously be able to talk to him and kind of the rest of our team here. All right, so models kind of, you see there's like a little bit, it's not really a leak. It's just like the model has to warm up, put weights and so on. So you have utilization here. So this utilization is not great. It's kind of spiky. So you'd like have to fuse a bunch of kernels and stuff to make this work well. But anyways, so developing a studio, super fast. I don't know how few minutes of doing this right now. And basically what's interesting now is because I've debugged this on the CPU, I can just, on the GPU, I can do multi-node real quick. So I'm going to Control-C this, and I'm just going to spin this up into multi-node in a few seconds. So I'm going to install the app called multi-node. I pick it up. I find the script that I want to scale. So it's finetune, right? Yeah. And you could pass in, this is a batch script here, so you can pass in whatever parameters you want, but we don't really need to do anything. So here I'm going to choose 8 GPUs. So this one has four 810Gs on it, and then there are 2 nodes of that. And I'm just going to run this. This is 8 GPUs. Now, I didn't change anything. I didn't install dependencies, change anything about the code. The studio, when it does something like multi-node, it like replicates environment everywhere. So it means if you got it to work in the studio, it won't fail. And because I'm using PyTorch Lightning under the hood, it just knows how to automatically distribute and scale itself. You can use PyTorch and TensorFlow and JAX and all that stuff. There's just a little bit more work you have to do. I'm gonna let this guy run for a minute. And as soon as we get the machines, we'll see that it's up and running. All right, CodeLlama. How are we doing with CodeLlama? So super slow, but it's to be expected. It is a huge model. But just first impressions, let's just look at the code real quick. So PyTorch Lightning import, okay, so the imports don't seem to have an issue right now. Why are we typing stuff? See, again, I'm telling you, this model is over engineering. Like I'm seeing stuff you don't need to be doing. And like you could have done this and then import all the other things after, right? So it is seeding more things. So the other one didn't really seed anything before, so that's fine. I don't know. You can call it over engineering. Some people call it more rigorous. I don't know. I tend to think that you should start very simple and then add complexity as you need to. Okay, this is going to take a little bit of time, right? So I want to see if my multi-node job is working well. I just think like this is wild. Once it runs, we can claim success here. But like, what's wild is like I went from. I mean, I know PyTorch Lightning obviously, but like I haven't looked at the code or read it in many years because obviously we're building these cool tools for everyone in the world. But this model definitely just kind of got all the code in there. I was able to sanity check it, put it together, so you could have dropped your model on there, And then I was able to fine tune it on the studio itself. Now, fine tuning, look, I think strictly speaking, I don't actually think this model is fine tuning, because the technical definition of fine tuning is that I am probably tweaking some parameters of this model. So however, if I look in here, I see that all the weights are being optimized, right? Ideally, probably would have frozen this here and then only fine-tuned this. In an LLM, it's like 20 different techniques about like, what do you fine-tune or not? Do you fine-tune this layer, that, or how many, or do you like backwrap into the embeddings or whatever? So that's what the fine-tuning will. So if you're trying to figure out like, do I fine-tune or pre-train? If you take a pre-trained model like Llama 2 and you unfreeze everything and you train and then you start training with something, you're technically pre-training but also fine-tuning, but you know what I mean, because you don't have anything frozen on there. If you freeze some parts, you're fine-tuning, right? What works for what instances and what data, it's more like a science question, so it's really up to you and you should try them out. But probably the deciding factor there is like, do you have a lot of data, and then how much you want to spend. If you have a lot of data and you want to spend a lot of money, pre-trains from scratch is probably going to be the best thing for you, right? If you don't have a lot of data, you don't have a lot of money, then you just fine-tune. So you just unfreeze a few layers, get some, make the model be more specific to your data. That's what fine-tuning does. And then you can use it, right? But in this case, we're not strictly speaking fine-tuning. I could just change this and just say self, for example, self.model.freeze. I think that's how you do it. Or you can do like with, I remember this, with torch.nograd, I think. It's been a while, right? You basically do that. Oh no, that won't work. Yeah. So you'd have to do the forward pass independently, right? So you'd probably define this as a separate layer and then kind of put them together. But yeah, so it's how you mix it up. All right, I really want to give this Llama 70B a chance to do its thing. In the meantime, let's see what's happening. All right, so this thing did train. It's pretty fast. Oh, it's going. Nice. All right, multi-node training. Check this out, right? I don't know if you guys have ever done this, but like there's utilization here. It's all going well. And I can see across the whole cluster what's happening. So all the GPUs are running. Let's look at the logs to sanity check. Yeah, it's going well. Oh, yeah, I mean, it's super fast. It reached 10 epochs really quickly, right? So all the machines are shutting down right now. Yeah, super fast. I mean, I just gave this tiny model 16 GPUs, right? Which is insane. And then you'll see Tensorboard here as well, but the model's already shutting down. So yeah, I mean, that's wild, right? Like, so again, fine-tuning, pre-training, it's really not that complicated. You just need the right tools, right? Okay, CodeLlama 70B. Man, this is super, super over-engineered. I literally told it not to use a data module, right? Do not use data module, right there. So yesterday it told me, gosh, low battery, it's fine. Yeah, yesterday it told me that it couldn't do something because I literally was like, can you count to 10 or something? And I said, oh, it's not allowed. So model super PC. Maybe I just need a different version of this model. So we'll try other versions. We'll have the team test out a few variations and see if we can find a 70B that works pretty well. But look, nevertheless, I think it's super exciting, the fact that like Meta keeps releasing these models and they're pushing a lot more. The open source community is doing what we can to continue to make sure that we have this accessible. I think it's really important for everyone to support this because, you know, it's kind of like, imagine back in the day if only a few companies had computers like IBM, right? And you didn't have a personal laptop. Then pretty much the internet and everything else, I can't say that it won't exist, but it would have been pretty hard to do. So it's really important that AI becomes open and democratized and available because, yeah, you know, some of us in the research community can grab this model and figure out like what's going on, right? Like if I were in my PhD right now, I'd like start prompting this thing, like looking at the gradients, trying to understand like what's being updated, what's not being updated, and why, messing around with prompts. So also, if you're in a PhD right now, don't get discouraged. I actually think there's a ton of cool research right now that you can do on these LLMs as well, right? And then multimodal for sure. So anyway, so this is kind of the state of things. So just to summarize, Mixtral works really well. Mixtral was able to give me code in a few minutes to fine-tune a model I then took that, ran it in a notebook, then Sanity checked it. This was once GPU only. I probably should have Sanity checked it on 4 GPUs, but once it runs on 1 GPU and you're using PyTorch Lightning, it's no difference between 1 GPU and like 1,000 GPUs. So then I went ahead and just scaled it, and I did multi-node very quickly, right? All the files that came from this are available, by the way, already. So if I go up into the studio, then I see that I have, I'm gonna go here. Yeah, so the data that I showed you, right? So I connected an S3 bucket is here, right? And then if I go into jobs, I can see the, yeah, so this is the model that I just trained. And then I'm just gonna copy all that stuff here. Sorry. What do I need to do? All right, let me just go grab certain files then. So copy this R. Oh, yeah, sorry. I forgot to put this path here. Okay, so node 0 is root node 0 is the only one that like has checkpoints and stuff. All right, so and then I can look at the Tensorboard logs here real quick. Where are you here? Let's see, I might have to, yeah. So I copied over the checkpoints here, and then Tensorboard just reloads automatically, which is great. So you see, just to kind of prove to you that this did work. So this went up to a few epochs. Train loss went down a lot, and val loss went down a lot. Yeah, so val loss is good. This thing, if I removed all the, I'll tell you why it didn't continue. Probably, I mean, this data set's so small, right? But max epochs 10, yeah, should have gone faster. Yeah, batch size, oh my gosh, yeah, this is crazy. Batch size is 256. This data set's so small, like you're done in a few minutes. So literally minutes to fine tune models, usually, right? It's not gonna take that long. Okay, so back to our friend, good old Llama 70B. Yeah, wow. Super over-engineered code. But you know, let's see what it's actually. Oh, is it giving me a notebook? What is this syntax? Oh, it might be giving me a notebook here. I wonder if it works. I mean, it's giving me different transforms, right? So what are these transforms compared to this? These are like simpler, random flip. These look right. Yeah, I don't know. I mean, are these the C410 standard deviation and means? That would be interesting. So maybe it is better. Resize 224. No, this thing's just over engineering. Yeah, it's over engineering, guys. Maybe try a harder problem, but like apparently having this model try to fine tune another model, and it's adding like loggers and stuff. This is wild. Yeah, I'm good. Well, I'll keep trying and see if I can find a good example of this working. But like so far, Llama 70B is fine, most likely. I'd like to see maybe better ways of prompting it. Mixtral, however, killing it, amazing. And in the context of a studio and a notebook, like you can do a lot of damage, which is cool. Anyways, thank you guys. If you like this kind of videos, definitely subscribe to the channel that I'm putting together. And my job here is to basically try to show you guys like real workflows without editing and show you what things are like and how they actually work, right? And hopefully you learn a lot here. And thanks for watching.